Imagine a historical conflict, say World War II, but throw in a real game changer like advanced artificial intelligence.
Yeah.
How different would things look?
It really makes you think, doesn't it? How history could be completely rewritten.
Exactly. And that's what we're doing today, a deep dive into this, well, this fascinating, pretty complex, and sometimes, yeah, unsettling world of the AI arms race.
Mm-hmm. And we've pulled together quite a mix of sources for this one. We've got the basics from Wikipedia, on the AI arms race itself, and also WWI Tech.
Okay.
But we also dug into detailed analyses from places like RAND, legal viewpoints from ASIL, even engineering perspectives from ceatengineering.com, stuff on AI governance, ethics, that whole dual-use tech issue.
Right, the tricky stuff.
Yeah, and believe it or not, even a Reddit discussion about how tech gets adopted in warfare historically. Found some interesting bits there, too.
Huh, interesting. So our mission today really is to unpack what's going on with this global AI competition.
Right.
We want to draw parallels from history, those big tech leaps during wartime, explore the ethical side of AI in the military,
It's huge.
and figure out how we even start to govern a technology moving this fast with this much potential. So let's get into it. So this term AI arms race, it's really about a global competition ongoing now, but it kind of kicked off properly around, what, 2010?
Yeah, roughly then. And it's mainly, the big players are the United States and China pouring in massive investments.
Okay, the U.S. and China.
And it's interesting how they're going about it. The U.S. is leading on the innovation front, mostly driven by the big private tech companies, that Silicon Valley engine.
Right, the Googles, the Metas,
Yeah.
OpenAI.
Exactly. Whereas China, well, they're really pushing AI progress with these huge government-backed initiatives, very state-driven.
So different models.
Totally different. But both are building out serious AI infrastructure, developing their AI workforces. It's a real race.
And it's not just about who gets the best tech first, is it? It's raising these big global worries, ethics, data privacy.
Oh, absolutely. And the need for regulation. People are getting nervous.
Yeah.
And speaking of huge initiatives, that brings us to the Stargate project. Remember that? Announced in 2025.
Stargate, right. That was OpenAI's Sam Altman and then President Trump.
That's the one. Aiming to build just enormous AI infrastructure in the U.S. The numbers are staggering, like a projected $500 billion by 2029.
$500 billion, wow.
Yeah. For advanced data centers, custom AI chips, even focusing on sustainable energy to power it all. It's positioned as this huge push to keep the U.S. ahead globally.
And I remember people comparing it to
The Manhattan Project.
Yeah.
That's the kind of scale they're talking about.
Which is a good transition, actually, because this idea of an arms race, it's not new, right?
Yeah.
Wars have always pushed technology forward.
Exactly. Wars put this incredible pressure on nations, demanding resources, demanding solutions, and that spurs innovation like nothing else.
Like radar.
Radar is a classic example, yeah. Huge developments during World War II. Or, the internet itself.
Right, but
ARPANET, yeah. Started as a military project, funded by the U.S. Department of Defense back in the 60s. Just trying to connect computers reliably.
And the space race, too, that must have played a role after Sputnik.
Oh, definitely. Sputnik went up in '57, huge shock to the U.S. system. That directly influenced things like ARPANET funding and obviously kicked U.S. space technology into high gear.
And World War II specifically, just an explosion of tech across the board. Vehicles, weapons, communications.
Incredible pace. You had jet fighters suddenly making propeller planes look ancient. Tanks evolved massively from their early days.
And aircraft carriers taking over from battleships as the main naval power.
Right. And think about Germany's innovations. They had early smart weapons like glide bombs.
Stuff that could be guided.
Yeah. And the first cruise missile, the V-1 flying bomb. And then the big one, the V-2 rocket.
The first ballistic missile.
First ballistic missile, yeah.
Yeah.
Reached the stratosphere. It's the direct ancestor of ICBMs. It's fascinating, actually, the lead scientist on the V-2.
Von Braun.
Wernher von Braun, yeah. He later helped design the Saturn V rocket that took us to the moon. Just shows how this military tech feeds into other areas.
And going back to that Manhattan Project comparison for Stargate, the sheer scale of the original project is just mind-blowing.
It really is. At its peak, nearly 130,000 people working on it.
Wow.
And the cost, equivalent to about $27 billion today. But here's the kicker. Over 90% of that cost.
What was it for?
Building the factories. The huge industrial plants needed to produce the fissile material, the plutonium and enriched uranium.
So it wasn't just the science, it was the industrial scale-up.
Exactly, which really highlights what something like the Stargate project might involve. It's not just code, it's building a massive physical infrastructure. An entirely new industrial base for AI power requires that kind of national commitment.
Which brings us neatly to this core challenge, the dual-use dilemma.
So many advanced technologies have this built-in problem. They can be used for good civilian stuff, but also for potentially harmful military or spying purposes.
And AI is like Exhibit A.
Totally. Civilian side. Autonomous vehicles, amazing healthcare diagnostics, understanding language, recommendation engines, stuff we use every day.
Right. But flip the coin.
And the military uses it for enhancing precision, maybe reducing human casualties in some cases, improving defense strategies. It's the same core technology, just different applications.
And that's where the ethical questions just flood in. Accountability. Who's responsible if an autonomous weapon makes a mistake?
Proportionality. Unintended harm. It's huge.
And we see this elsewhere too, right? Like cybersecurity tools. Encryption is great for privacy.
But it can also be used by adversaries in cyber warfare. Data analytics helps businesses.
But can be used for espionage, even biotech, like gene editing. Incredible medical potential.
But the potential for misuse, like engineering biological weapons, is terrifying.
So with tech this powerful and double-edged, how do you even start to manage it responsibly?
Yeah, that's the multi-billion-dollar question, isn't it? It really hammers home that ethical oversight isn't just like a philosophical debate. It's practical. It's crucial.
So what does that look like?
Well, you need accountability for the engineers, clear processes to prevent harm, making sure everything complies with the law, transparent regulations.
And it can't just be one country doing it.
Absolutely not. These technologies don't care about borders, so you need global collaboration, some kind of shared understanding, shared rules. It's imperative.
Okay, so let's talk specifically about one of the most pointed military applications. Lethal Autonomous Weapon Systems, LAWWS.
Right. Systems that can identify, target, and engage without a human pulling the trigger, basically.
And these aren't science fiction anymore.
No, not at all. We've got concrete examples. The U.S. Navy's Phalanx system on ships, it can automatically detect and shoot down incoming anti-ship missiles.
Okay, that's defensive.
Mostly, yeah. But then you have things like Russia's Lancet 3 drone. It's a loitering munition, flies around, finds a target autonomously, and hits it.
And that Turkish drone, the KAR-RG, there were reports it was used autonomously in Libya.
Yeah, back in 2020. That report caused a big stir, suggesting a drone might have hunted down and engaged human targets fully autonomously for the first time, though the details are still debated.
So countries must have very different views on this stuff.
Oh, massively different. Russia, for example, has flat out rejected any ban on laws. Basically said even if there was a ban, they might ignore it.
Okay, that's one end of the spectrum.
Then you have the European Parliament saying, hold on, humans have to stay in the loop. Meaningful human control, oversight, decision-making power.
But isn't it complicated even within Europe?
Very. Because while the Parliament takes that stance, you've got individual EU members, France, Germany, Italy, Sweden, actually developing these kinds of systems.
So they're saying one thing institutionally, but doing another nationally.
Kind of, yeah, or at least there's a tension. And then you have Austria calling for a complete ban. So the EU itself doesn't really have a single unified position, which makes it hard to act cohesively.
In Germany, you mentioned.
Yeah.
They have something specific.
Yeah, they developed something called an active defense system. Apparently, it can react to threats completely autonomously in less than a millisecond.
Less than a millisecond. That's faster than human comprehension.
Pretty much, which raises all sorts of questions about control.
And we're seeing this play out in real time, aren't we? The Russia-Ukraine war. People are calling it a drone war.
Definitely. Both sides are using AI extensively, and Ukraine specifically is really pushing the envelope with drone swarming techniques.
Swarming. So multiple drones coordinating.
Autonomously, yeah. Working together in a real conflict zone. It's not just theory anymore. And the scale of production is incredible. Ukraine reportedly made around 2 million drones in 2024.
2 million.
Yeah. And apparently, like, 96% of those were made domestically. Huge scale up.
Wow. So this widespread use, the swarming, it must be putting massive pressure on international law.
It absolutely is. You had scholars like Professor Noel Sharkey warning way back in 2007 about an emerging arms race in autonomous weapons.
Over 15 years ago.
Yeah. And now there's definitely growing momentum for clearer rules. The UN Secretary General, the Red Cross, they're jointly calling for new treaties, new prohibitions or restrictions. The pressure is building.
So Thinking about governance,
Yeah.
you mentioned the Manhattan Project earlier. A lot of people draw parallels between trying to govern nuclear weapons back then and trying to govern AI now.
It's a really powerful analogy, and the similarities are quite striking when you look closely.
How so?
Well, think about it. Both involve highly specialized kind of choke point materials. Uranium for nukes.
And for AI.
The argument is it's the super advanced computer chips, the ones you need to train the really powerful AI models.
Okay, specialized materials. What else?
Rapid scientific breakthroughs leading to that arms race dynamic we talked about both happen very, very quickly. And critically, both have this potential for truly catastrophic harm that doesn't respect borders. A nuclear war, or some argue uncontrolled superintelligence, these are global threats.
And there are lessons from the nuclear history, right?
Right.
Like the Brooke plan you mentioned earlier.
Yeah, that's a key one. That early attempt at international control right after World War II, it failed.
Why does it fail?
Well, a big part of it was perception. The U.S. proposed the plan, but they were the only ones with the bomb at the time. So the plan looked to others, especially the Soviets, like an attempt to just lock in America's advantage, not a truly fair, equitable effort to control the technology for everyone.
So the lesson is
Yeah.
trying to set the rules when you're way out ahead can backfire.
It can make long-term cooperation much harder. Yeah, it breeds suspicion. You need buy-in. And that's tough if everyone thinks you're just trying to keep your lead.
So applying that to AI,
Mm-hmm.
how does compute fit in? You said it's like the uranium.
Well, some analysts argue it's the best analogy we have for a potential control point. Because think about it. The production of these cutting-edge chips...
It's complex, expensive.
Exactly. It's detectable, you know who's making them and selling them. It's excludable, you can, in theory, restrict access. It's quantifiable, you can count chips. And the supply chain is really concentrated, just a few companies and countries dominate.
So the idea is maybe you could control the chips like you control nuclear materials.
That's the thought. Could you create something like a compute suppliers group, modeled after the nuclear suppliers group, to manage the trade in these advanced semiconductors? It's a really active area of discussion.
Interesting. And that leads to ideas about international bodies for AI.
Yeah, various proposals are floating around. Some look loosely at the IAEA, the International Atomic Energy Agency, as a model.
So an international body that could.
Maybe inspect AI systems, audit their training data or processes, test them for safety, perhaps even put limits on how powerful deployed systems can be. Lots of ideas. But getting agreement is, well, the hard part.
Definitely. So beyond these global ideas, what are individual countries or alliances doing? You mentioned the U.S. Department of Defense has principles.
Yeah, they adopted 5 principles back in February 2020, focused on what they call responsible AI, or RAI.
Okay, what are the key ones?
2 really stand out. Reliable, meaning the AI's uses are explicit and its effectiveness is tested. And governable.
Governable, meaning?
Meaning you have ways to detect if the AI is doing something unintended, and crucially, you have the ability to switch it off or disengage it if needed. That human oversight piece.
Makes sense. How does that compare to what allies are doing? France, for example.
France talks a lot about trustworthy AI. They link that closely to robustness, making sure the AI works reliably, and security, and they explicitly address risks from, say, biased training data or algorithms malfunctioning.
Yep.
They even get into this interesting ethical debate. Is it unethical if soldiers face different levels of risk because one side has technology that lets them fight from further away?
That's a deep question. What about others, like Australia?
Australia focuses on lawful AI, making sure it complies with laws, obviously. And they use ethical risk assessment tools. They also talk about contestability. Contestability.
Yeah, the idea that decisions made by AI should be challengeable, reviewable. They see it as making AI more responsive to democratic oversight.
Canada.
Canada's been working hard on data governance, setting up ethical principles for how data is used, though apparently actually implementing these principles across the board is maybe a bit slower, a lower priority perhaps than some other places.
And Germany. You said they were more focused on arms control.
The government seems more focused on the arms control aspect, yeah.
Yeah.
While German industry is quite active in developing the tech, there's an interest there in looking at AI governance across its entire life cycle, from design to deployment to decommissioning.
It sounds like there's a lot of overlap in principles, but different emphasis.
Definitely. Different national priorities, different philosophical approaches sometimes.
And NATO. As an alliance, how are they approaching it?
NATO emphasizes a human-centric approach, always keeping the human element core to developing new capabilities.
And they see standardization, getting everyone on the same page about safe and ethical AI, as directly linked to interoperability, making sure different allied forces can work together seamlessly.
Which is key for an alliance.
Absolutely. And there's a specific forum for this,
Ah,
right?
yeah. The AI Partnership for Defense, convened by the U.S. Joint Artificial Intelligence Center, the JAIC.
Right. That brings together countries like Australia, Canada, France, Germany, the Netherlands, the UK, quite a few others too.
And what's the goal there?
It's really a place to exchange views, hash out what responsible AI actually means in practice, and try to align those different national approaches we just talked about. Crucial for building consensus.
Okay, so let's loop all the way back to that opening thought experiment, World War II, but with AI.
Yeah. How would it have changed things?
Fundamentally, I imagine. Logistics, for starters.
Whoa, massively. Imagine AI optimizing supply lines, predicting exactly when a tank might break down, calculating ammunition needs automatically. It could have been a huge efficiency boost.
And espionage.
Yep.
Intelligence gathering.
AI could sift through mountains of intercepted messages, reconnaissance photos, reports, finding complex patterns, maybe predicting enemy movements at a speed and scale humans just couldn't manage. That's a colossal strategic advantage.
And history definitely shows that adapting tech, especially enemy tech, can be decisive.
Absolutely. You mentioned the First Punic War earlier, Rome copying that Carthaginian ship.
Right, and inventing the Corvus boarding bridge.
Exactly. Turning sea battles into land battles, basically, playing to their strengths. Brilliant adaptation.
What are some other examples?
Well, you've got the Macedonians under Philip II. They took the Greek phalanx formation.
And it made the spears longer.
Yep, the sarissa. Outranged their opponents. Simple, but devastatingly effective adaptation. The Mongols learned siege warfare from the Chinese, using artillery to take down fortified cities they couldn't previously conquer.
And during World War II itself.
A famous one is the U.S. capturing an intact Japanese Zero fighter early in the war.
Yeah, the Akutan Zero.
That's the one. They took it apart, flew it, figured out its strengths, but also its weaknesses, like the engine struggling at high altitude, the lack of armor, no self-sealing fuel tanks.
And they used that knowledge.
Absolutely. Developed tactics specifically to exploit those weaknesses in future air combat. Huge difference. Even thinking further back, the Comanche adopting the horse from Europeans.
Right, they became incredible cavalry.
So effective, they basically stopped Spanish expansion northward for a significant period. It shows how adopting and mastering a new technology can totally change the balance of power.
So if that kind of rapid learning and adaptation was possible then,
Yeah.
imagine throwing modern AI into that mix.
Exactly. An AI that could analyze enemy tech, figure out weaknesses, suggest new tactics, or even new designs, all in near real time.
It just accelerates everything. The pace of technological development, strategic prediction. It could completely change how a war unfolds, maybe even who wins.
Profoundly modify the outcome, yeah. It moves beyond human learning speed.
So quite a journey we've been on today. We've looked at this ongoing AI arms race, seen how war has always been this engine for tech leaps.
Yeah, grappled with those really tough ethical questions around dual-use AI and autonomous weapons. Law?
Looked at the lessons from nuclear history for governing AI, that whole compute as uranium idea.
And examine how different countries and alliances are trying to build frameworks for responsible AI in the military.
A lot to take in.
It really is. And if you try to connect all these threads, think about the bigger picture, it leaves you with a pretty important question, I think.
What's that?
Well, as AI keeps getting more powerful and those lines between civilian and military use keep getting blurrier, what new responsibilities does that place on us? On nations, sure, but also on the technologists building this stuff, and maybe even on us as individual citizens.
Responsibilities to shape its future.
Yeah, to make sure we're actively guiding it, ensuring that the benefits we get from all this incredible technological progress really do outweigh the potential risks. How do we manage that balance?
Definitely something to mull over as you continue your own deep dives into the world around you.